Now, the intervals of time will be different in dynamic systems. And here, if the intervals of time were constant, this would be a relationship which always maintain a constant relationship. Now, for orbital relationship is supposed to vary to the 1/3 power of time, which would basically show intervals of time stay relatively constant for a long period of time before there's any significant deviation in terms of how we would measure intervals of time. And this is shown based on, if it was just based on a light clock, and we weren't considering any other dynamic relationships or dynamic where there's a balance between spatial and inertial forces, the intervals of time defined by such kinds of relationships. And since these intervals of time are shorter, it is interesting to compare the cumulative measure of these intervals of time. And here we see basically if the intervals of time were constant, then the total amount of time would elapse would be, if there was the age of the universe, be the age of one universe of time would be the experienced time elapsed. Under the proposed model, the total experienced time ends up being 1.5. So if a dynamic system were in resonance, starting at the very beginning of time, 1.5 times the age of the universe will have actually elapsed to get to our present location in time. And so it's a slightly different, a less dramatic variation, whereas in the old one we can see it went up to infinity before, when we just considered effects of observable space. Now, I think I'll stop here and get ready for the next section, because it's a long section.